All right, so we are going to be working on our standard algorithm or our long division. Per our earlier strategies, I've already written out our multiples up top, and I'm going to relate this method to the box method. So the first thing we're going to do, as we were doing earlier, is to look and see how many times I could put 5 into 9, or what is 9 divided by 5. I'm going to do that by finding my multiple that is equal to or less than 5. And that would be 5 itself. So that would be 1 times. So we're subtracting 5. Same here. It would be 5 goes into 9 one time and minus 5. So that's going to leave us with 4 on both. Now on our box method, we would take our 4 and move it up into the next box. But in our standard algorithm, we're actually just going to bring that one down. So our 6 is going to come down and join our 4. So really, as you can see, we have a 46 here and a 46 here. So our boxes are actually the same, again, except for this one's vertical, where this one is horizontal. All right, so now we're going to do the same thing. We're going to find our multiple that is equal to or less than the greatest one to 5, which would be the 45 here. So we know we're subtracting 45, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9 times. And I'm going to do it down here as well. And that leaves me with 1. Again, 5 times 9 is 45, which leaves me with 1. Again, on my area model, I'm moving 1 up. And on my standard algorithm, I'm going to be moving the 8 down. All right, so our final step, because we're on our last number, is to see how many times I can put 5 into 18. Again, right here, I have it in my box method. The greatest time I can do that is 15. So I know I'm subtracting 15, which is 1, 2, 3 times. Again, 5 can go into 18 3 times for a total of 15, which leaves me with 3. Since 3 is less than my divisor, I do have a remainder or a leftover of 3. Okay, I'm going to do it again with a larger number. I have my multiples of 4 written out. Again, up to the 9th multiple, because there will only be 1 digit over each box or over each digit. I'm going to start by asking, can I put 4 into 3? So I'm looking for a number that is equal to or less than 3 in my multiples of 4, and there is not one. So in this, we're going to have to write a 0 up top. We can't do that. And then 4 times 0 is 0, so that's what we're subtracting. All right, on both of those, that's going to leave me with 3. Box method, I'm bringing my 3 up. Traditional model or area method, or long division, we're going to bring it down. So we're going to now see how many times I can put 4 into 30. I'm going to look for my greatest multiple that is equal to or less than 30, and that one will be 28. So I know I'm subtracting 28, but I've got to figure out how many times that took me. 1, 2, 3, 4, 5, 6, 7 times. I write my 7 up at the top. And now I can do my subtraction. 3, I've got to borrow. 3 becomes a 2, and the 0 becomes a 10. 10 minus 2 is 8. I'm sorry, 10 minus 8 is 2, and then 2 minus 2. So same down here. Makes that a 2, that makes that a 10. 10 minus 8 is 2. All right, so bringing my 2 up, and on my traditional or standard algorithm, I'm going to bring my 4 down. So how many times can I put 4 into 24 this time? I have an equal to this time. So I have 1, 2, 3, 4, 5, 6 times, which was 24, which is what I'm subtracting. Again, bringing this one up, bringing this one down. I cannot put 4 into 1. So again, I'm going to have to put a 0 here because I can't do that. So 4 times 0 is 0, leaving me with 1. 4 times 0 is 0, leaving me with 1 for a remainder of 1. Again, my quotient is everything on top including the remainder.